Welcome to the Foundry by Forge College. If you were with us for the last explainer, you know we mapped out the plans for a comprehensive token sale. Well, today is where things get really fun. We're taking the topic of composing sale components and refund strategies and translating that exact architecture into a fully functional, modular, smart contract vending machine for your capstone project. Yep, a Web3 vending machine. And our main goal? Making sure it doesn't just, spit out all the sodas the second someone kicks it. So, let's dive right in. Here's our engineering schematic for today's explainer. We are going to quickly look at the blueprint, build out our essential modules, follow a user named Alice on her journey, map out the refund path, tackle testing components, and finally wrap it all up with deployment prep.
All right, kicking things off with Section 1, the blueprint, turning plans into interfaces. So you might be wondering, how do we actually turn a token sale plan into code without creating an absolute tangled mess of spaghetti code? I mean, it's so tempting to just start mashing your keyboard and coding logic right away, right? But defining exactly how our vending machine's pieces communicate first, that is how we guarantee safety. If you've ever dealt with tightly coupled smart contracts, you know the absolute dread I'm talking about. You pull one noodle and the whole plate falls off the table. When contracts depend on each other's entire implementations, you get these nasty circular dependencies. If one gear breaks, the whole machine explodes. And let me tell you, fixing an exploded machine on the blockchain, not a fun afternoon. So our strategy here is to completely isolate our components using interface stubs. Think of these interfaces like electrical sockets. By defining the exact shape of the plugs, the inputs and the outputs, before we even build the actual appliances, we make it crystal clear what data passes across our boundaries without tying anything in knots.
Moving right along to Section 2, Essential Modules, the 5 gears of the vending machine.
Let's check the schematics here and see how we build this out into 5 perfectly isolated modules that pass data cleanly. This is actually a standard practice across all the Forge College learning tracks. Visualizing this as an actual physical vending machine makes it super easy to grasp. Okay, so the SaleManager, that's the coin slot. It orchestrates the entire sale lifecycle. The whitelist? That's your grumpy bouncer scanning IDs to make sure no one exceeds their purchase cap. Then we have the TokenDistributor, which is the actual dispenser dropping the digital goods. The VestingManager acts as a sort of time-release safe for any post-sale token locks. And the RefundHandler, that's your trusty coin return chute. Keeping these 5 gears entirely separate is absolutely crucial. It's how we ensure we don't accidentally, say, wire the coin return chute directly to the dispenser and bankrupt the whole operation with free snacks.
Which brings us to Section 3, Alice's Journey, Tracking a Contribution.
Let's look at how these gears turn in the real world by following a hypothetical participant. We'll call her Alice. Walking through a concrete scenario like this exposes exactly where our data handoffs occur. Imagine the sale is live and open. Alice drops 3 Ethereum into the SaleManager coin slot. Now, the manager doesn't just swallow that crypto blindly, right? It instantly pings the whitelist bouncer to check her ID and verify she hasn't hit her limit. If she's clear, the SaleManager accepts the funds. But here's the kicker. It immediately delegates the accounting to the specialists. The RefundHandler steps in and logs her exact contribution balance. It also updates a mapping so that off-chain indexers, think of them like slick receipt printers for your user interface, can accurately show Alice her history. So the SaleManager just directs the traffic, and the specialists do all the heavy lifting.
Now for Section 4, the refund path, handling failures safely. So that brilliantly illustrates the happy, everything went perfectly setup. But what happens when it's time to actually finalize the sale? We really need to plan for 2 very different outcomes here. If we succeed and hit our funding targets, awesome. An admin triggers a successful finalization, the dispenser and the time-release safe take over to allocate Alice's tokens, and refunds are permanently locked out, done and dusted. But what if we fail to hit our soft cap? Well, the system must fail gracefully. The manager flips a simple Boolean flag, basically turning a giant switch from true to false, marking the sale as failed. Because of this single elegant flag, the token distributor stays completely locked down, and the refund chute, our refund handler, opens up. It is a clean, binary outcome. Success or failure, there is literally 0 ambiguity.
Now, listen up, because this is the absolute most crucial point of the whole explainer. To prevent thieves from draining your smart contracts via reentrancy attacks, only the refund handler should ever track or execute refunds. Think of a reentrancy attack like a scammer asking a cashier for a refund, and before the cashier can even update the ledger to say the refund was paid out, the scammer puts on a fake mustache and asks for it again and again and again. By making the refund handler the absolute single source of truth and putting strict guards on its functions to ensure the ledger updates before the money is ever handed over, we perfectly isolate our risk. The SaleManager coin slot doesn't do refunds. Only the refund handler does, period.
All right, Section 5, Testing Components, Safety Inspections.
Before we load this machine with real tokens, we absolutely need a rigorous safety inspection so our smart contracts don't, explode on the blockchain. And because we built 5 distinct modules instead of a tangled mess, testing is actually pretty easy. We start by compiling and linting our interfaces. Think of linting as an incredibly aggressive spell checker that yells at you for bad code grammar. Next, we write unit tests, like making sure the grumpy whitelist bouncer strictly rejects random unknown addresses. Finally, we run integration tests using mock or fake contracts. This allows us to simulate cross-module flow, like Alice's journey, with fake money, proving the SaleManager calls the right methods at exactly the right time. It's essentially a completely risk-free fire drill.
And that brings us to our final section, Section 6, Deployment Prep, the Golden Rules.
We are now ready to take our compiled interfaces and prepare for actual deployment. Stick to these 3 golden rules, and I promise it'll make your life an absolute breeze. First, enforce single responsibility. As we established, your coin slot shouldn't try to be a coin return. Keep jobs separate. Second, freeze integration contracts early. Lock in those blueprints before you start laying the heavy bricks of complex business logic. You don't change the floor plan once the foundation is poured, right? And third, design events for testability. Every time a module executes an action, it should leave a reliable, on-chain paper trail that we can easily verify. Follow these rules, and for sure, you'll sleep very soundly at night.
So, your interfaces are clean, your refund path is secure, and your logic is beautifully isolated. But will your smart contracts actually survive the wild west of a public mainnet? Moving from a safe, local test environment to a live network introduces terrifying gas optimizations, complex orchestration, and some seriously tricky environment-specific traps. But hey, that's for next time. This wraps up our explainer for the Building Token Sale Mechanics module of the Applied Solidity Development track. Be sure to visit forge.college to dive into our next lesson on scaling and real-world deployment and explore more of our resources so you can launch your Web3 projects with absolute confidence. See you then.